Hello. Now in this session, we will discuss about different reflector antennas. Before going to discuss that different types of reflector antennas and their design, we will understand first what is the reflector antennas and what are the basic parts in the reflector antennas. Then we will move to the reflector antennas types and the design. So here I have given one picture. If you come across the board reflector antennas, so directly we will get one picture in our mind. That is nothing but that is what we are using in a DTH applications. That is a dish antenna. So if I say something about reflector or a parabolic reflector means, so all of us get easily in our memory is that is a DTH applications, a dish antenna. So here you can see there is two parts. There are two things are available. One is, so this is one, and this is two. Now we will move to the introduction to the reflector antennas. Along with this picture, what I have given here. So reflector antennas mostly preferred for its high directivity. So we are mostly preferring where we need to get a higher directivity, their reflector antennas are considered. The second is they're mostly suitable for long distance communications. So in deep space or satellite communications, so we are using these reflector antennas. So generally in reflector antennas, we have two elements. So these are two parts. So first one is active element. Second one is passive element. So here I have just given two parts. Okay. So the first one is passive element. The second is active element. Now I just already here marked number 1 and 2. So number 1 is on so parabolic reflector. That is circular one metallic disc is there. Okay. This is a passive element. Second one I just marked number 2 is active element. So why we say this two are like active element and passive element is already we discussed in Yaguda antenna array. What is the passive element and the active element? So active element in antenna, which is receiving signal directly. That means so feeding is directly given to the antenna that is called as active element. And also it is a primary antenna. So and also it is named as primary antenna. Second element is that is said to be passive element because it is not receiving signal directly. It is fed indirectly. That's why it is a passive element. Here see that which is a passive element is it is a reflecting surface. This reflecting metallic surface is a passive element. So we say it is a reflector antenna or secondary antenna. So throughout this session, we will go to learn about this secondary antenna only. Okay, we will understand what is this secondary antenna or reflector antenna. What are its types? So what are its types and in which way we can feed this secondary antenna? See here, the primary antenna or active element. So I'm using one horn antenna. It's actually one horn. So if you see in a womb, So upon this on antenna, some like plastic mug or some plastic cover will be placed on this to protect it from environmental damages. But it don't require that much safety. So because here antenna is already encapsulated into one plastic case only. So here this DTH dish antenna not used here used for a transmission of electromagnetic signal. So here this setup we are using for a reception of electromagnetic signal. It is a television signals. Now let's see that. So we are preferring reflector antennas mainly for two purposes. One is for a longer distance communications. Second is for a high frequency applications. So that high frequency application means what is the range of microwave frequencies. If we calculate what will be the lambda of this micro range of frequencies, then we can get an idea of the physical size of these reflector antennas. Because most of the times antenna size should be proportional to the operating wavelength, which should be calculated from the operating frequencies. So most of reflector antennas are very small because of a micro range of frequencies applied as input. In this reflector antenna, that is in this secondary antenna, we are using another one antenna to give feed indirectly. That is, we need one active element to excite our reflecting antenna indirectly. So this active element or active antenna may be different types. For example, it may be dipole antenna or a horn antenna or a slot antenna. But a commercially available DTH service, we are using the horn antenna as an active element in the reflector antenna. This all active element, or we can say it is a primary antennas. Indirectly, the reflector antenna is excited. That's why it is called as secondary antenna. So what are the basic types in this reflector antennas are? So there we can have three basic types. That's based on its geometrical shape. First one is a plane reflector. Second is a corner reflector. Third one is curved reflectors. This reflector antenna used to modify the radiation pattern of a radiating element. That means what is the radiation pattern of the active element? That will be modified by properly choosing the reflector antenna type. That is the main purpose of using reflector antenna. That means to modify the radiation pattern of a active element or active antenna. That is the first. Second, due to this reflector antenna, we can eliminate or reduce the backward radiation from the active element. That's why we kept a reflector element in a negative antenna. The same way, we properly design our reflector here, it is possible to reduce the backward radiation from the active element. so that we can concentrate most of the electromagnetic signal in the desired directions. Okay, see. Here I have given different types of reflectors with its arrangements. So the first one is, here we have one rectangular sheet. This rectangular sheet is attached with the one of a dipole antenna. Here, how we are feeding this reflector antenna is through this of a dipole antenna. So, of a dipole antenna is directly gets electromagnetic signal feed. From that only, this is secondary antenna or reflector is excited. That's why this of a dipole is called as a driven element. This metal large flat sheet is called as a reflectors. Second one is the reflector size is reduced. The same configurations. It's a small flat sheet reflectors. And if you want to improve much radiation further, you have to reduce this flat sheet into a minimal sieve. So this is the way how we get a Yaguda antenna design here. See that here we have a large flat sheet, which is reduced into small flat sheet, which is further reduced into very similar shape of lambda by 2 antenna. That means our reflector also converted to thin linear in shape, very similar to this driven element. So both are very similar. Only that weight changes is maybe it is a different length compared to the rather than driven element.